find the force of gravity between three particles, they make a new equation or a new relationship, and it goes something like this. Big G, Newton's universal gravitational constant, times m1 times m2 times m3, divided by the whole distance across the whole thing. And that doesn't work. You can't do it that way. So there are a bunch of forces in here. The 4 kilogram mass is pulling on the 3 kilogram mass, and the 3 kilogram mass is pulling on the 4 kilogram mass, and the 5 kilogram mass is pulling on the 3 kilogram mass, and the 3 kilogram mass is pulling on the 5 kilogram mass, and the 4 kilogram mass is pulling on the 5 kilogram mass, and the 5 kilogram mass is pulling on the 4 kilogram mass. And they can either move or not move depending on if they're fixed or not. Here's the thing. We're only talking about the 3 kilogram mass, so we only care about the forces exerted on the 3 kilogram mass. Also, the particles aren't moving. Forget about that. Doesn't say they're moving. A lot of students will try to complicate the problem with that. The distances don't change. They're fixed. Okay? Now, in addition to this, the second part of the problem was to find the direction. So let's add this. It says find the magnitude, and I'm just going to put down below, and direction. Okay? All right, so we're going to use the law of universal gravitation, and first we're going to find out the individual forces exerted on the 3 kilogram mass by the 4 kilogram mass and the 5 kilogram mass. So these forces look something like this, although this is not scaled. This is going to be the force of 4 on 3, and this one is the force of 5 on 3. Okay? Force of 4 on 3 and the force of 5 on 3. It's kind of hard to see that 5 on 3 because there's some glare. All right, so we'll start out with the force of 4 on 3. I'm going to put it up here because this is going to be a long problem. It's going to take all of our paper. So the force of 4 on 3 is equal to G m4 times m3 divided by the distance between 4 and 3 squared. Okay. Now I'm going to commit a sin here. And I'm not gonna put units, okay? Because if I put units, the equation is going to get so long, I'm not going to fit it into this little space. But don't do that. Do as I say, not as I do. Yes, very hypocritical. I tried not to do that, and I felt really bad first period when I did this problem, and I told him that, and I was like, oh, I shouldn't have done that. But oh well, already done it. So, all right. So sometimes I feel bad about the stupidest things. Okay. All right. So. G is 6.67 times 10 to the minus 11. Okay? The mass of 4 is 4. And the mass of 3 is 3 kilograms. Right? And the distance between them, we need to use our geometry, which is what? The distance formula. Wow, that's great. Okay, so we're going to use the distance formula. We're going to break out the Pythagorean theorem. And we're going to solve for the length of the hypotenuse of this right triangle. You probably use the Pythagorean theorem more than anything else, but there's a lot of geometry you'll use. Okay, so these grids are in meters, and so we have the length of this side is going to be the square root of the adjacent and opposite side, and it's going to be 1, 2, 3, 4 squared plus 1 squared. Now, in the law of universal gravitation, you have to square the distance. Remember, it's inverse square law. So what happens to the radical? Yeah, it gets squared, right? Goes away. Okay, so go ahead and solve for that. Use your calculators, and you can check my answer. Katie, what do you got? Yeah. That's correct. Okay, we'll go ahead and put the units there. It's newtons. Okay. Next, we need to solve for the force of 5.3. That's just G m5 m3 divided by d5 3 squared. So Newton's universal gravitational constant. Don't you love saying that?
Yes, sir.
Just makes me feel important. Okay, divided by the distance, again. What did we say, Finney? Use the distance formula, right, from the Pythagorean theorem. Okay, and so we're going to divide by the square root of 3 squared plus 3 squared, and of course we're going to square that. I'm only putting that in there so that later on you can go back and you can see, yeah, he did use the distance formula, and then he did squared, and we squared the radical and got rid of it. Anybody got it? That's correct. Go ahead and put units of newtons. Okay, now, here's what we need to do. We need to use our knowledge of vectors and vector resolution and vector addition to solve the problem. Okay, so let's make a list of things that we need to do. Okay. And I'll tell you what, let's draw a free body diagram first. I did that in another class, and I think it seemed to help. These forces are exerted in kind of this way. I'm going to draw a little free body diagram just to kind of illustrate this. Here is F43, and here is a representation of F53. Okay? Now, we cannot add those together using conventional addition because they are not parallel. If they were, we could add them. But we can resolve them into their components. And their components are perpendicular pieces that, when put together, form the original vector. Okay? So the x component of F43 looks like this, and the y component looks like this. So here's F43y, and this is F43x. F43x. Okay, and then this one is the x component of F53, and this is the x component of F43. F53x, F53y. Okay? Those have a partner that is parallel. So F53x and F43x are parallel, so we can add them using conventional math. And F53y and F43y are parallel, so we can add them using conventional math. So first thing we're going to do, we're going to use vector addition to find the resultant. And that is first resolving into components. Second, we're going to add like components. Third, we're going to use the Pythagorean theorem to find the resultant. I need a t in there, don't I? And we're going to use the tangent function, to find the direction. So that's the next thing we're going to do. So we've already used law of universal gravitation. We're done with law of universal gravitation. The rest of it is vector math. Okay? So we need to find or resolve the vectors into their components. So here is the first one, F43x. Okay? So F43x, we found that F43x is F43 times the cosine of the angle. Okay? Now that angle is measured from the positive x-axis counterclockwise. Okay? And we don't have it. We don't know the angle. We could measure it on this diagram, but I don't know how precise it would be. I would choose not to do that. Okay? Because we have the coordinates of the vector. So we don't really need the angle. Okay? The cosine of an angle is the adjacent over the hypotenuse. And we can measure the adjacent and the hypotenuse. So we don't need the angle to find the ratio using the cosine. So F43 times the adjacent over the hypotenuse is equal to F43 times the cosine of the angle. So what is the adjacent over the hypotenuse? Well, it's hard to see because this vector right here, it's not in the first quadrant. If this was in the first quadrant and the angle was measured from the positive x-axis counterclockwise, then you would immediately see that the x component, it's the adjacent side. But since this angle is a right angle that has one angle that's greater than 90 degrees, which is like impossible. I like to picture the right triangle as kind of flipped inside out. Okay? So the adjacent side is the x side. The adjacent side of this right triangle is -4. So that's what we're going to write down. -4. And the hypotenuse, we've already found using the distance formula. And it is the square root of 4 squared plus 1 squared. So go ahead and find that out. F43 is 4.71 times 10 to the minus 11 times -4 divided by the square root of 17. Felicity, what did you get? Okay. Anybody? Jocelyn? -4.57?
Just a couple of reminders for tomorrow. It is a Tuesday with the brand new one-to-one shirts. If you have not purchased one, you do not have one. This is only for those who have a one-to-one shirt.
Let's go ahead and find the Y component.
Faculty and students. We're going to dismiss. We're required to have a car drill
Yeah.
once a month. We're going to dismiss again for a car drill this afternoon. Whenever the alarm goes off, students, make sure teachers, you're going to have to help us with this. Make sure that sure that your students go out the appropriate exit. Even though that might not be the exit they exit each afternoon. If you're a bus participant, you need to make sure that you make your way around outside the building to the bus stop as quickly as possible. We're going to dismiss early enough so that should not be an option, but it should be a problem for those that have transportation through our bus services. Again, it's important that we go out the appropriate exit. We need to be out within 2 minutes. You know, this is a drill. Let's make sure they weren't stopping, waiting for our friend to exit as quickly as possible. If you're a mentor or mentee in Mr. Nash's group, we will let you back in the building as quickly as possible. Please make sure you report to the appropriate location for that group. Mr. Nash's mentors and mentees. If you have tutorials, you may come back into the building. If you have rehearsals, etc., we will let you back in a very timely fashion. So make sure that we exit as quickly as we can. Go to the appropriate exit. Again, if you're a bus driver, make sure that you go outside the building around to the bus stop. You should have plenty of time. We'll do this probably towards the last 7 to 10 minutes of class. Thank you.
What was the question?
It's negative because it's going to
The left. Yes. Say it again. It is below 1. Multiply times F43.
Holding at the stations. Perkins is the only one who will pull the station. Thank you.
Okay, so if we multiply 4.71 times 10 to the minus 11 times -4 divided by the square root of 17, we get the x component, which is -4.57 times 10 to the minus 11. Okay? All right, so we've broken the first vector, F43, into its x and y components. Now we're going to break F53 using the same technique. F53, x, is equal to F53 times the cosine of the angle. F53 is also, F53x is also equal to F53 times the adjacent side over the hypotenuse, which is equal to F53 times 3 over the square root of 3 squared plus 3 squared. And just because we're going to have to go faster because we're going to have a fire drill here in a second. 3.93 times 10 to the minus 11 newtons. Okay, that's the component. F53y is found in a similar fashion. F53 times the sine of the angle. It's also equal to F53 times the opposite over the hypotenuse. And that's equal to F53 times minus 3 divided by the square root of 3 squared plus 3 squared. Okay, same distance, same hypotenuse. And that turns out to be minus 3.93 times 10 to the minus 11 newtons. Okay, we're almost done. Rx is equal to F43x plus F53x. And if you add those numbers together, you get minus 6.40 times 10 to the minus 12 newtons. And Ry is equal to F43y plus F53y, and that's equal to minus 2.79 times 10 to the minus 11 newtons. Okay? If you think about it, we've moved over to the negative, to the left with Rx, and we've moved down with Ry, and here's R. We're going to use the Pythagorean theorem to find the hypotenuse of this new right triangle. R is equal to the square root of Rx squared plus Ry squared. And that, when you calculate it, is equal to 2.86 times 10 to the minus 11 newtons. Okay? So we're just putting back together again the pieces that we then found by adding components. Okay? Now here's the part that tends to confuse students. The angle, the direction, is found using our tangent function. The tangent of an angle is equal to the opposite over the adjacent. So the angle is equal to the arctangent, which is just the reverse function of the tangent. The arctangent of Ry, which is our opposite, divided by Rx, which is our adjacent. The arctan of the ratio of minus 2.79 times 10 to the minus 11 divided by minus 6.4 times 10 to the minus 12 is the arctan of 4.36, which is equal to 77 degrees. Now, I don't know about you, but this R is not at 77 degrees. It's somewhere between 180 and 270. Okay? The thing is, the tangent function and your calculator cannot tell the difference between dividing two negatives and getting a positive or dividing two positives and getting a positive. All your calculator knows is it is finding the arctangent of a positive number. Those numbers can either be coordinates of a vector in the first quadrant or a vector in the fourth quadrant, or a vector in the third quadrant. Our vector belongs in the third quadrant. So the angle is actually 77 plus 180, which is equal to 257 degrees. And that's our answer. The same is true for vectors that are either in the second or fourth quadrant. Vectors in the fourth quadrant have negative y's and positive x's, and vectors in the second quadrant have negative x's and positive y's. Either case, the ratio is going to be a negative number. And it's going to give you an arctangent. It's going to give you an angle value when you use the arctangent of a negative number in the fourth quadrant. You then need to go back and look at your answer to see if you need to add 180 degrees to it or not. Okay? So this is your final answer. Yeah?
So how did you determine that we needed to add the 180?
Because I looked at the picture and I looked at the sign of my x and y value. The sign of my x and y value are both negative, therefore it belongs in the third quadrant. 77 degrees is in the first quadrant, so I add 180 to it. It's always opposite. It's either correct or opposite.
How do you do that?